All right, we are on day 5, mixed factoring. So no new types of factoring, but we are going to go and try just a bunch of mixed problems all together to make sure that no matter what we're dealt, we know how to factor it, because we are going to do a bunch of factoring. The next unit will be more important. So in number 1, it says completely factor the following. All right, remember the first type of factoring we always check for is greatest common factor, and there is a 5 in common, so we're going to go ahead and pull out a 5. Left over would be a 4 minus x squared. We're going to have to be super duper careful because we don't want to leave our answer not completely factored. Completely factored means pull apart until you can't pull apart anymore. And this right here is a difference of 2 perfect squares. And so we have to make sure that we pull it apart. All right, so 2 sets of parentheses. We'll take the square root of 4, which is 2 and 2. 1 with a plus, 1 with a minus, and the square root of x squared is x. And don't forget to bring down the 5. None of those factors can be factored again, and so we will box it up, and this one is finished. And one thing I want to point out, remember how that 4 came first, and so when we broke it up, the 2's came first. They have to be that way. We cannot flip it around. If we had x plus 2 and x minus 2, it would not be the same. The addition factor would be, but the subtraction one would not be the same. And so that is why the order is important, and it matters that they stay like that. Okay. Number 2, greatest common factor. The answer is yes. A 2 can be pulled out, and so we will go ahead and pull out a 2. Left over would be a to the 4th plus 3a squared plus 2. And before we box this up, I'm going to say that this looks like a trinomial with a twist. And so we're going to set up our X box off to the side, and we're going to look for numbers that multiply to get me 2, and at the same time add to get me 3. And those numbers are 2 and 1. 2 times 1 is 2. 2 plus 1 is 3. And because it is an easy trinomial with a twist, we will go right to the factors. We just have to remember that the twist is that this is a to the 4th, and so it's broken up into a squared and a squared. 1 gets the plus 2, 1 gets the plus 1, and don't forget to bring that 2 down. Checking out those factors, none of those factors can be factored again, and so this one is finished. Okay, let's take a look at number 3. In number 3, there has to be a greatest common factor. Both of those numbers end in 0. So I'm going to go ahead and think that 10 might be the largest. Okay, so we're going to pull out a 10. And what we have left over would be a 4 minus 25x to the 14th. And before we box that up, I'm going to go ahead and say that this is another difference of 2 perfect squares. So we're going to break that up into 2 sets of parentheses. Square root of 4 is 2. 1 followed with a plus, 1 followed with a minus. And the square root of 25x to the 14th is 5x to the 7th. 5x to the 7th. And don't forget to bring down the 10. And we're going to scope out our factors. And I don't believe any of those factors can go again. And so we're going to go ahead and box them up. Okay. Number 4, part of 4 we can't do because we skipped cube factoring. However, we can do the very first part, which is checking for a greatest common factor. And there is one, 8. And so if we go ahead and pull 8 out, left over would be an x cubed minus 8y to the 9th. And that is done. This is technically a difference of perfect cubes, but we did not teach that this year. And so this to us is done based on the types of factoring we know. Okay, number 5. First type of factoring we should always check for, again, greatest common factor. Of those Numbers, I'm pretty sure that 3 goes into 12, 3 goes into 57, and 3 goes into 15. And so we're going to go ahead and pull out not just a 3, but a negative 3. And we pull out a negative anytime that first term is negative. If that first term was positive, we wouldn't pull out the negative. Okay, this is the only time we pull out is that when the first term using greatest common factor is negative, we pull out the negative. We're also going to pull out an x. Left over would be a 4x squared. This is going to have to be a positive since we pulled the negative out. 19x. And this is going to have to be a negative so that the negative we pulled out times the negative here will give us the positive 5. Okay. And I'd say we're done, but that looks like a nice trinomial. However, he does look like a hard trinomial because of this 4 out in front. So when we put our x box up, our multiply would normally be the negative 5, but with that 4 there, it's going to be a negative 20 for our multiply. We can also give this a sad face because hard trinomials make us do more work. Our add is going to be the positive 19. And I'm going to say that the numbers have to be 20 and 1. Except to get a positive 19, this one's going to have to be negative. So that should add, and when I multiply him, should multiply as well. All right, remember the sad face. He's a hard trinomial. He's got more work to do. So this first term needs to be rewritten. In fact, a lot of people are going to be like, well, what happens to the 3x? You know what? Let's get him out of the way and let's just drop him straight down so that we don't have to worry about him until the end. Okay. All right. Now we're going to go ahead and rewrite the 4x squared. I'm going to put the plus 20x next, then the minus 1x, then the minus 5. We're going to group the first two, group the last two. Out of the first group, we can go ahead and pull out a 4x. Left over would be an x plus 5. Out of the second group, we're going to have to pull out the negative, and there's nothing else in common, so a 1. Left over would be an x plus 5. Again, in factor by grouping, those have to match, and we're going to go ahead and put that factor right next to the negative 3x. And the guys on the outside, squish them together, you get 4x minus 1. And those factors cannot be gone again and factored over, so we are finished with this one. Okay. Number 6. Let's go ahead and see. Is there a greatest common factor? And I'm going to go ahead and just by looking at the variables, yeah, there's an a in common. Is there a number? 3 goes into 6, 3 goes into 15, and 3 goes into 21. So I'm going to go ahead and say that it's got to be a 3a. Left over would be a 2a squared minus 5a minus 7. Okay. And inside those parentheses, that looks like a hard trinomial. So we can give him a sad face again because he's going to make us do more work. We'll throw out the x box up, and that 2 in the front, that makes it the hard trinomial, and the negative 7 in the back will make our multiply negative 14. And our add will be negative 5. Our numbers are going to have to be 7 and 2. And to get a negative 5, 7 is going to have to be negative. So that multiplies to the negative 14, and it adds to the negative 5. Okay. Again, remember our sad face. So we have to remember to rewrite. However, let's get that 3a out of the way. Drop them right down into our answer so we don't forget them. Okay. Now let's go ahead and do 2a squared. I would like the plus 2 next. Don't forget to put an a on it. Then the minus 7a, and then the minus 7. And we're going to go ahead and group the first two, group the last two. And out of the first group, we can go ahead and pull out a 2a, left with an a plus 1. In the second group, it's got to be a negative, and 7 is in common. When it comes out, a will be left, and a plus 1. There's those matching pairs. And so now we're going to go ahead and pull out a plus 1. We'll put it right next to the 3a we dropped down. Guys on the outside, squish them together. 2a minus 7. And no factor can be factored again. And so this one's finished. Okay, 2 more on the front side. All right, number 7. There is nothing in common. First one has no numbers. The last term has no letters. Does not follow the format of a D2PS. It is not a trinomial, so I'm going to go with factor by grouping. Group and group. Out of the first group, I can pull out x squared. Left over would be an x plus 2. Out of the second group, 27 does go into 54 twice, so I'm going to pull out the negative 27. Left over will be an x plus 2. My x plus 2's match, and so x plus 2 becomes my first factor. Guys on the outside, squish them together. X squared minus 27 is my second factor. I was trying to see if this was a perfect square, but 27 is not a perfect square. It is a difference, and that's an even exponent. But there is no square root of 27 that comes out to be a nice number, so it's not perfect. And so this is finished. Okay, number 8. First type of factoring we check for greatest common factor. And just by looking at the variables, I can see that there's an x squared in common, and 2 goes into 162. So we're going to go ahead and pull out a 2, x squared. 2 goes into 162 81 times. So there'll be an 81 minus x to the, remember, when you multiply, you have to add the exponents. And so this is going to have to be an 8. So that when we distribute x squared times x to the 8th, you add the exponents. 2 plus 8 is 10. But inside here, this is a difference of 2 perfect squares. 81 is perfect. There's a difference in the middle, and that's an even exponent. So we're going to go ahead and break them up. The square root of 81 is 9. 1 gets a plus, 1 gets a minus. Square root of x to the 8th is x to the 4th. And don't forget to bring down your 2x squared. And, this factor right here can go again. That's a difference. 9 is perfect, and that's still an even exponent. And many people will think that this one can also go again, but that's not a difference in the middle. That's a sum of perfect squares, and it can't be factored. So we can go ahead and just bring down the 2x squared, bring down the 9 plus x to the 4th. That cannot be factored, but this one can. This is a D2PS. Square root of 9 is 3 and 3. 1 with a plus, 1 with a minus. Square root of x to the 4th is x squared and x squared. And looking again, that last one, people might give a double take. It is a difference. Your exponent is even. However, 3, if you try to take the square root of 3, is not pretty. Therefore, the square root of 3 is not perfect. And so we'll leave it like that. All right, we'll see you on the back side.